Okay, this lecture is going to go with section 2.2 in the book called Measures of the Location of Data, but I'm titling it something more specific. And I'm saying median, quartiles, and percentiles because that's what we're actually going to be discussing. Let me fix my microphone here for a second. Okay, hopefully that's a little better. Okay. So median, I want to define this for you. The median of a data set is one way. It's not the only, okay, that's why I said one way of marking the center of the data. Okay. In parentheses, I'm going to put the median. Oops. May be one of the data points or may not be. You'll see in a couple minutes. Okay. Half of the data points will be less than or equal to the median and half of the data points will be greater than the median. Okay, and here's how you find the median. Okay, number one. List the data points in increasing order. That means from smallest to biggest. Let's say one of your data points is 5 and you record that data point 4 times. Then you could either list out 4 number 5s, or you can just list out 5 and then make an indication that there's 4 of them. Okay? All right, number 2. If there is an odd number of data points, in that case, that means that one of the data points will be right in the center, and that will be your median. Okay, if there's an odd number of data points, the one in the center is the median. Okay. I left out a word there. Okay, there we go. Okay. If there's an even number of data points, then it's very, very slightly more complicated, but I hesitate to even use the word complicated because it's not complicated at all, but it's just a tiny bit more. If there's an even number of data points, in that case, there will not be one data point right in the center. The center would fall sort of like you could say on the comma between two data points. Okay, and in that case, the average of the two closest to the center, the two data points, I should say, closest to the center, the average of those two is the median. Okay, let's do just a couple of examples. Okay, look at that list of data. Let's see how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8. There's 14 data points. Okay, so if I want to find the median, the first thing I do is I arrange them in order. 1, 1, 2, 2, 4, 6, 6.8, 7.2, 8, 8.3, 9, 10, 10, and 11.5. Okay. Now there's 14 of those data points. So if I were to go right to the center, where would I be? The center would be right here, because there's 7 data points here and 7 data points here. The center is not one of the data points. So what you do to find the median is I should have left that there actually. To find the median is you take the 6.8 and the 7.2 and you find their average. Do you know how to do that? You do 6.8 plus 7.2 divided by 2, which is 14 divided by 2, which is 7. And that's your median. Okay? Let's do one more example. Let's say we have this data and I want to find the median. So I put them in order: 14, 15, 15, 21. Oops, I left out 19. You got to be careful. That's the thing, because if you miss one, then you got to erase stuff and go back. 19, okay. 21, 28, 28, 32, 36, 41, 47. Okay, how many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the center happens to fall right on the 6th one, and that's your median. Okay. So that's how you find median. Pretty darn easy. Okay, now let's move on. Let's talk about quartiles. Okay, there's things called the first, second, and third quartiles. So the first quartile okay, that's a number where 1/4 of the data points are equal to or less than this number, and 3/4 of the data points are greater than this. Okay, and now I'm going to write down, this is just going to take a little bit of time, so let me just write it down and then have it pop up all at once for second quartile and third quartile. Okay, the second quartile is a number where half of the data are equal to or less than this number, and half of the data points are greater than this. Now that might seem familiar, but just stick a pin in that for a minute, and let's write down third quartile. Okay, whoops. Okay, the third quartile is a number where 3/4 of the data are equal to or less than this number, and 1/4 of the data points are greater than this. Okay, now, if we think about this, let's start with the second quartile. Do you recognize that definition? That's just the median. The second quartile is the median. Okay? The first quartile is the median of the data points before the median. The book says the median of the first half, but I prefer to say the median of the data points that fall before the median. And for the third quartile, that's the median of the data points that fall after the median. Okay, so I'm going to list out a new data set and we will find all three quartiles. Okay, let's look at this data. I had to write the numbers small so that it would all fit on your screen. Because the numbers are in the hundred thousands, then there are commas in the numbers. And therefore, I used semicolons to separate the numbers. Okay, so let's see how many numbers there are. There's 13 of them. So we first find the median. Okay, now there's 13 numbers. So the seventh one will be right in the middle. There's our median. It's 488,800. Okay. Now, that's also called the second quartile. Now, to find the first quartile, you look at the numbers in front of the median. You don't count the median here. Look at the numbers in front of it. There's 6 of them. So, we look at the middle too. Okay, because the median, the middle, the center of those 6 falls right between those two numbers. Okay? And this is going to be the first quartile. We write Q with a little 1. Okay? And it is the average of those two. So we go 230,500 plus 387,000 divided by 2, and we get 308,750. That's your first quartile. This number is your median or your second quartile. And then to find the third quartile, you look at the data points that fall after the median. How many are there? 1, 2, 3, 4, 5, 6. And so the middle of those 6 will be right here between the third and the fourth one. Right between those two. Okay, so we write Q3 equals 639,000 plus 659,000 divided by 2, and we get 649,000. That's your third quartile. So basically we're separating the data points into fourths. Okay, 1/4 of the data is before that gray line and 3/4 is after. Half of the data is equal to or before that gray line and half of it's after. 3/4 of the data is before that gray line and 1/4 is after. So we've separated the data into fourths, basically. Okay, and look at this. Let's count these. There's 3 numbers here, 3 numbers here, 3 numbers here, 3 numbers here. They're all the same size, except I know this is the dirty little secret. The 488,800 was also one of the data points, and I didn't just highlight that in yellow. Okay, because the median fell right on that number. So to separate, if you look at those yellow highlighted parts, there's 3, 3, 3, and 3. So you say, oh, it's separated perfectly into 4 equal pieces, but not 100%, because there's actually not 12 data points, there's 13, and 1/4 of 13 is 3.25. So those 4 groups of 3 aren't exactly 1/4 of the data. Just a tiny bit less. But you can't always avoid that. Okay? So I hope that makes sense. Now, we'll do another one in a minute, but let me point out something else to you. Okay? There's also something very important called the interquartile range, which is the distance let's do this in what color? Let's do this in blue. The distance between these two is called the interquartile range, or what the book calls IQR. Okay? Interquartile range. It's just the third quartile minus the first quartile. And what that does is it tells you one way of measuring how spread out is the center half of the data. Okay? So in this particular case, our interquartile range equals what? 649,000 minus 308,750, and that is 340,250. That's our interquartile range. So what that tells us is that if you look at the center half of the data, they are spread out over a range of 340,250. That's how wide that gap is. Okay? And if you remember something that I mentioned before called outliers, do you remember that? It's where you collect a bunch of data points, and then there might be some that don't appear to belong with all the others because they're so far away from where all the other data points are grouped up. Okay? And there's not a specific rule for deciding how far away is too far away, but there is a rule of thumb. One of them is this: a data point is suspected of being an outlier if it is, I'm going to write this down in a minute, less than 1.5 interquartile ranges below the first quartile, or more than 1.5 interquartile ranges above the third quartile. Let me write that down. So, a data point is suspected of being a potential outlier because the thing is, oftentimes statisticians want to ignore outliers. And so you have to decide what numbers should I cross off the list. Okay, so a data point, I forgot to put the word point, is suspected of being a potential outlier if it lies let me erase that word lies. Let me say if it is less than 1.5 interquartile ranges below the first quartile, or greater than 1.5 interquartile ranges above the third quartile. Okay, so what you do is you find quartile 1 and then you subtract 1.5 times the IQR. Okay? And any number that is smaller than that is suspected of being an outlier. And then you also do the third quartile plus 1.5 times the interquartile range. And any number bigger than that is suspected of being an outlier. And remember what the interquartile range is. That's quartile 3 minus quartile 1. So technically this is Q1 minus 1.5 times Q3 minus Q1. And if you really like doing the algebra here, you could distribute that 1.5 and so you end up with 2.5 times quartile 1 minus 1.5 times quartile 3. Okay, but the thing is, nobody ever actually does it that way. That's too much. I'm not even going to leave that on the screen. Okay, what you do is you find the interquartile range first. This is my advice. Find the interquartile range first, and then you just calculate that and that. So let's do that for our data set above, and let's see if there are any potential outliers. Let's scroll back up. Okay. Let's give ourselves some room. Okay. So what I'm going to do let's do quartile 1 minus 1.5 times the interquartile range. So that's 308,750 minus 1.5 times 340,250. Okay, and that equals negative 201,625. Now, are there any data points that are less than that? Certainly not, right? All of our data points are positive. So there's not anything less than that negative number there. So that means I'm not worried about any outliers at this end over here anywhere. Okay? Now let's see if there's any outliers at this end over here. So I'm going to do quartile 3 plus 1.5 times the interquartile range. So that's going to be 649,000 plus 1.5 times 340,250, and that equals 1,159,375. So are there any numbers bigger than that? Yes, there are, aren't there? This one right here. So I suspect that that number is an outlier. Now, what do you do with that information? We'll talk about later. It's a possible outlier. And so if I was a statistician, these numbers, by the way, are home prices. And if I was a statistician studying the home prices in this town, I would probably cross out that biggest number. Because that's probably, you know, some mansion that is not at all indicative of the houses in that town. And so if I'm wanting to get a good idea for how much houses cost in that town, I may want to ignore that one mansion that belongs to a movie star who happened to move into this town. You see what I'm saying? But right now, we're not going to worry about that. Right now, we're just worrying about finding potential outliers. We are not deciding that it is definitely an outlier, and we're not doing anything with it. Okay? Okay, let's look at this table here, okay? Because this is oftentimes how data is recorded, is in a frequency table, not listed all out. So we're going to look at this. We're going to find the median, the first and third quartiles, the interquartile range, and we're going to see if there's any suspected outliers. Okay? So we only need to look at the first two columns, which shows the actual data points and each data point's frequency. This is the amount of sleep that students got per school night, the number of hours, okay? Let's make sure you remember how to read this. Two people said they get 4 hours of sleep. 5 people said they get 5 hours of sleep. 7 people said they get 6 hours of sleep, and so on and so on. Okay, now let's figure out how many people they asked. Okay, let's write down the number of data points. Okay, I'll show you where we find that. We look here at this column, the frequency. You see 2 people said 4 hours, 5 people said 5 hours, 7 people said 6 hours, and so on and so forth. So those numbers tell us how many people were asked, right? Just add these numbers up. What's that going to come out to be? I think it's 52, but I added very quickly. Let me see if I'm right here. Yeah, I was close. It's 50. I was just adding it in my head as fast as I could. Okay, so it's 50. I'm going to just double do that addition in my head and double check that. Yeah, I just added up again. It's 50. Okay? So I want you to think about this. We could list all 50 numbers out. I could write 2 4s, 5 5s, 7 6s, and so on. But that's going to take a long time, and to be honest with you, it's kind of juvenile, right, to have to do that. I think that we're college students here. Let's be a little bit more sophisticated about it and just think about this, okay? There's 50 data points. Let's find the median. What did we say the median was? When there's an even number of data points, the median is the average of the middle 2, right? So in this case, the median will be the average of the 26th, sorry, let me say that again, the average of the 25th and 26th data points, okay? Median, which is also called the second quartile, okay? That's going to be the average hang on here, my pen's not working. Okay, average of the 25th and 26th data points. So let's find them. Okay, let's just count. Here we've got 2, and then 5 more is 7, and then 7 more is 14, and then 12 more is 26. So do you see that the 25th and 26th data points are both going to be 7s, right? You see how that is? If you don't, I think you probably do, but if you don't, let me show you what else we could do. I can help you out a little bit. I could write 2 4s and 5 5s and 7 6s and 12 7s and so on. Okay, but we don't need to go any further because look, we can just count. I'll cross them off as I go. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23, 24, 25, and 26. Okay? So do that if you have to, but really practice. You should be able to figure that out just from looking at these numbers. Okay? All right. So the 25th data point is a 7 and the 26th data point is a 7, and so the median will be 7 plus 7 divided by 2, which is of course 7. There's our median or second quartile. Okay, let's find the first quartile. That's the median of the data points before the median, right? Remember, the median is halfway, in this case, halfway between the 25th and 26th data point. So the first quartile is the median of the first 25. 25 is an odd number. So which one will be right in the center? Will be the 13th one. So what is the 13th data point? There's 2 4s and then 5 5s. That's 7 data points so far. We need to go 6 more data points to get to the 13th one. And since there's 7 6s, then the 13th data point will be a 6. Okay, that's the 1 second here. Okay, that's the 13th data point. And that is a 6. That's our first quartile. Let's find the third quartile. How many data points are after the median? The median is between the 25th and 26th data point. So there's 25 data points after the median. 25 is an odd number, so the median of those 25 lands on the 13th one. So for the third quartile, we go to the first 25 data points and then 13 more, which is how much? That's going to be the 38th data point. Okay, which is the 38th one? So again, we have 2, 7 so far, 14 so far, 26. We need to go 12 more. And since there's 14 8s, then if we were to go 12 more, it would be an 8, right? So that's our third quartile. Now let's look for outliers. So we find the interquartile range. That's 8 minus 6. The third quartile minus the first quartile. So that's 2. That's our interquartile range. Alright, now let's see if there's any potential outliers. So we do first quartile minus 1.5 times the interquartile range. So that is 6 minus 1.5 times 2, which is 6 minus 3, which equals 3. Are there any data points smaller than 3? The answer is no. Okay, now let's check the other end. We go the third quartile plus 1.5 times the interquartile range, which would be 8 plus 1.5 times 2, which is 8 plus 3, which is 11. Are there any data points bigger than 11? And the answer is no. So it does not look like there are any outliers in this set of data.